exponents on integers and decimals. So exponents can only affect what they are next to. So let's look at this here example to see what this means. So we have in parentheses -3 raised to the second power. So because it's in parentheses, we're actually going to be multiplying -3 times -3, right? So we have two copies of this. Now in this one right here below, there is no parentheses. So this 2 only affects this 3. So what does that look like? It has it like this. So it's like 3 times 3 with the negative on the outside of the parentheses. So what does that mean for the product? So -3 times -3 is +9 because there's two negatives, so that makes it positive. Below, we have 3 times 3, so that's 9, but there's that negative. So that means -9, and this is +9. So the difference is only in the parentheses. So because it's in parentheses, that means we have to include the negative to be multiplied. And below, we do not have to because it's not included. It's only on the number. So we have to only multiply 3 times 3 in this case. So let's look at some more examples here. So example 1, we're going to solve for the following. We have -5 raised to the third power. Well, notice we don't have a parentheses, so we're going to go ahead and leave the negative right here. In parentheses, we're going to put 5 times 5 times 5. And we're going to go ahead and multiply. So 5 times 5, right, that's 25. And then we're going to go times 5. Well, if you think about it, if you have quarters, right, and then you go ahead and you have 5 quarters, that means you have $1.25. Or in this case, because this isn't a decimal, there's no decimals, it's just 25 times 5, it's 125. Right, and another way to think about it is 25 times 4 is 100, plus another 25 would be 125. But the thing is, we have this negative sign, so we need to go ahead and add it. So our answer then is -125. So let's look at another example. So example 2, we're going to solve for the following. We have in parentheses -2 raised to the fifth power. So let's go ahead and write this out. So we have -2, which gets multiplied by itself, right, 5 times. And so when we go ahead and multiply, let's go 2 times 2, right, that's 4, and that's +4, right, because negative and a negative make a positive. If we were to do it like here, -2 times -2, that's also +4. And then we have this -2. So now we have 4 times 4, right? I'm just making, this is the one I'm just dealing with. So 4 times 4 is 16, then times, and this is positive, then times this -2, and so 16 times -2 is -32. Now, if we were to go back, maybe you can just do this in your head where you go 2 times 2, well that's 4, times 2, that's 8, times another 2, which is 16, times another 2, which is 32. Since we have an odd amount of negative signs, you could just know it's negative, and it's 32. So maybe you don't need to go ahead and do all of this where you multiply the 2 together, multiply these other 2 together, and just make sure you carry everything down to make sure you multiply everything together. So there's multiple ways to get to the answer. And so you can go whichever way helps you keep track of everything. So now let's look at another example. So example 3, we're going to solve for the following. We have 1.5 raised to the second power. Right, so that means we have 2 copies of 1.5 that we're going to go ahead and multiply together. Well, let's go ahead and write it like this. And we'll go ahead and multiply. So 5 times 5 is 25. We're going to carry that 2, keep the 5 down below. 5 times 1 is 5, plus 2 is 7. Now we're going to have a placeholder rate of 0. Then we're going to move on to the 1. 1 times 5 is 5. 1 times 1 is 1. We go ahead and add, so it's 5 plus 0 is 5. 7 plus 5 is 12. Carry the 1. So we have 2. Then we have 2 decimal place values. So we're going to move the decimal over to the left twice. 1, 2. Right? Because there's 1 here, 1 here. So we have to move it over twice. So what's our answer then? It's 2.25.